Hello, we are in Chapter 6, Section 6.2, the quadratic formula. In this video, we are going to go over warm-up number 2, solving by completing the square. So if a quadratic equation does not factor even after isolating 0, you can always solve it using the method of completing the square. So we are going to solve this problem by the method of completing the square. Just to remind you, the idea of completing the square is to rewrite our equation in the form where the left-hand side is the square of a binomial and the right-hand side is just a number. So to achieve that perfect square trinomial on the left-hand side, we need to complete the square. So we keep x squared plus 6x on that side, and we will subtract 13 from both sides to leave ourselves some room to complete that square. To remind you, if the leading coefficient is 1, to complete the square, we need to add half of the coefficient standing by the first power of the variable x in this case, which is 6, squared to complete the perfect square trinomial on the left-hand side. So we are adding that half of 6, 3, squared in here. Of course, to keep the balance in the equation, we also have to add the same number to the other side, and 3 squared is 9, so we're adding 9 to the other side. Now, that left-hand side factors as a perfect square trinomial because 6 is 2 times 3, so we're going to have the square of x and then plus 3 because the sign in our binomial must match with that middle coefficient sign. And we simplify the number on the other side. Negative 13 plus 9 is equal to negative 4. Once we completed the square, we use the square root property that tells us that if we have the square of a number, then the number itself is plus or minus the square root of the number. So here, if we have the square of x plus 3 to be negative 4, then x plus 3 itself must be equal to plus or minus the square root of negative 4. Now we should remember that when we see the square root of a negative number, the first thing we do is to rewrite it using I as a complex number. So we have x plus 3 equals plus or minus the square root of 4 times I. And of course the square root of 4 is 2, so it's really x plus 3 equals plus or minus 2i. To finish solving for x, we subtract 3 from both sides. And to have the solutions in standard complex number form a plus or minus bi, we're going to have x equals negative 3 plus or minus 2i. Those are two solutions, of course. We have to remember that one of them is negative 3 plus 2i, and the other one is negative 3 minus 2i. And we can always say or between them.